This is section A19 of the BTEC Engineering Unit 7. We're on page 35 of the section A examples booklet. Now this follows on from the previous immediate sections. However, we are now moving into functions that are much more difficult to differentiate, and we have to use certain rules. This one will use what's called the product rule for multiplying products of functions. So as we move on towards A24, the functions we're differentiating are going to be much more complex and require much more work. So on page 35 of the examples booklet, as usual this is a video, not a lesson, so you may need to pause in order to take notes. You will definitely need notes in order to achieve on the actual assignment. So again we have to find the first and second derivatives of a function. This time it's s equals 2t minus 1 times 7t squared minus 8. So we need to differentiate for both these things. Now in this case we've got two brackets multiplied together, so we need to use something called the product rule to differentiate. So what we do is we call the first bracket u, so that's u equals 2t minus 1, and we call the second bracket v, so v equals 7t squared minus 8. Now differentiating both sides. So for the first case, du by dt, we take our number in front of the t basically. So this is just a quick reminder of the rules. If you've got t to the n, then you multiply by the power and reduce power by 1. If you've got mt plus c, you just need the m. So for the 2t minus 1, that's mt plus c, the m is 2, so du by dt is 2. We've got v equals 7t squared minus 8, so that starts with a t to the n start, so we multiply by the power, so dv by dt equals 2 times 7, and we would take 1 off the power, 2 take away 1. The minus 8 is the plus c bit, so that just disappears. So simplifying, 2 times 7 is 14. 2 take away 1 is 1. We don't need to write powers of 1, but if you write the 1, it's fine. You just leave it, it just automatically means power of 1. Right, so now we've got our du by dt and our dv by dt. The product rule, which will allow us to find ds by dt, is equal to v times du by dt plus u times dv by dt. So this is a particular formula that allows us to differentiate two things multiplied together. So basically from our formula, v times du by dt is 2 times 7t squared minus 8 plus u times v by dt, we've got 14t times 2t minus 1. Which we can multiply out and simplify. So 2 times 7 is 14, so we get 14t squared minus 2 times 8 is 16, plus 14t times 2t, which 14 times 2 is 28, t times t is t squared, 14t times minus 1 is minus 14t. Simplify, 14t squared plus 28t squared is 42t squared. We've got minus 14t and minus 16. Now, one could argue that we could have multiplied out these brackets at the start and got a function we could have differentiated using earlier rules. However, to be able to we have to be able to show that we can apply the product rule. So I'm using this to make it easier to get the second derivative for later on in the question. But you need to use the product rule to do the first differentiation. so that you can show you can use the product rule. You have to use the product rule. You have to use these special rules at least, trying to think, 6 times. So that's 1 time. We'll do it once for each of the resulting 5. Right, so differentiating, we've got 42t squared, so that's a t to the n rule. So multiply by the power, reduce the power by 1. So 2 times 42. Take 1 off the power, 2 take away 1. And we've got minus 14t minus 16. That's an mt plus c type. So we just need the number in front of the t, which is minus 14. Simplifying, 2 times 42 is 84. 2 take away 1 is 1, don't need to write powers of 1, minus 14. And again, we may need these formulae later, so s equals 2t minus 1, 7t squared minus 8, ds by the t, actually having it, we'll have that form, 42t squared minus 14t minus 16, second derivative, 84t minus 14. So for the later questions. Part B. So part B, we need to find the gradient at the 2 t values, minus 0.25 and t equals 1.25. So it's a case of sticking those numbers into the formula for ds by the t for the gradient. So, doing a negative number, I would put it in your calculator exactly as I'm going to write it. So 42t squared becomes 42, open bracket, minus 0.25, close bracket squared, minus 14, open bracket, minus 0.25, minus 16. If we do it like that in a calculator, it'll sort out any negative issues. So I'm doing that now. And I'm going to get minus 9.875. And then same sort of idea, but with t equals 1.25 instead. So 42 times, and basically same formula, but instead of minus 0.25 in the brackets, we can put 1.25 in the brackets. So doing that now. And I get 32.125. Again, that's what you need to do for the pass. When you get merit in distinction, you need to explain what you're doing, and you have to compare your answers to those obtained in the graphical method in A7. So bear in mind, just like the earlier sections like this, these are the actual answers, so you would say these are the actual answers, and then you would say, in my answers to A7, if they were close, you'd say those were good estimates. If they weren't close, they were bad estimates. So it doesn't matter if your estimates in A7 were good or bad, you just need, as long as you made the correct comment for your values. Part C, finding the turning point and the nature. So as we've done in recent sections, the turning point is when the s by the t is equal to 0. So we've got our quadratic, 42t squared minus 14t minus 16 equals 0. That's what our ds by the t is from part A. We need to solve that. We can use the silver calculators. So if we do mode 5, 3, Now the A, B and C in the column relate to the 42, the minus 14 and the minus 16. So you need to enter in values into the table given. So 42 minus 14 minus 16 equals, and it says x1 equals, but we're doing t values, so we've got either t equals 0.805986742. We're going to round it later once we've found the corresponding s values. Press equals again for the other solution. T equals minus 0.472653487. So we go back to the S equals formula. So we've got 2 times T, so 2 times 0.8 minus 1 close bracket 7 times 0.8 I'll write in the whole number, but that's what you'd have to stick into the calculator. Squared minus 8 close bracket equals. So we need to do mode 1 to go back to normal mode. So let's do that. 2. Sticking in the numbers. This equals minus 2.1129599381. So if we round into 2 decimal places, our point would be 0.81 minus 2.112 dp. Same sort of idea with the other value. Again, I stick it into the S formula. So the S formula being 2t minus 1 times 7t squared minus 8. Now, because we're squaring a negative number, we'll need to put brackets around it, so that it squares a minus as well as the 0.4. We get 12.52036679 to 2 decimal places minus 0.47 12.52. We need to do a second derivative test to test which type of points they are, so we need to stick our values into d2 squared over d2s over dt squared, so that's our formula, 84t minus 14, so 84 times 0.805 minus 14 equals, stick on the calculator, and we get a positive number. So we put greater than 0, and a positive number means that the point is a minimum. So remember, second derivative, if it's positive, your point's a minimum. If it's negative, the point's a maximum. So doing it with the other point, d2s over dt squared equals 84 times minus 0.47 minus 14. So same formula but different number that we're timesing by. So put the whole number in, 6534087 minus 14 equals, we get minus 63.7, which is clearly a negative number, so the point is a maximum. Now, we have to compare, to get the merits and distinctions, you need to compare your answers to those obtained by the graphical method in A7. So these are the proper answers. Your A7 answers are only estimates. So again, if they're close, you would say your graphical method answers were good. If they're not, if they're further away, then they're not good. Again, it doesn't matter how good your estimates were in A7, as long as you make the right comment related. So these are the right answers. Say how good your estimates are in comparison to that. Now, as usual, a lot of this maths can be quite complicated, so make sure at the very, very least that you're able to follow through with slightly different numbers, because the process is the same each time. So you're following through the process with different numbers. Best of luck.